Let's get started. So let me make it full screen. Okay, great. Yeah, so today is 13th, right? Yeah. So basically, this class is about communication system and components. So basically, we're going to focus on the wireless communication system. Okay, so anyone kind of learned this thing before? Oh, great. Yeah, from where? Like, what kind of classes did you take?
EEL4514C, I forgot what the class is, but wireless communication systems. Yeah, there's another class like that.
Okay, yeah, Okay. So what is the number again?
EEL4599.
4599. Okay, yeah.
Here.
I see. Okay. Yeah, great. Yeah, then maybe you have a very good, solid ground for this class. So, okay. Yeah, I think overall in this semester, so because we have classes on Monday, Wednesday, and Friday, right? And so every time we have 50 minutes. So we have about maybe like 40 classes in total. And so I will talk a little bit details on our schedule and the logistics later. So first of all, about myself. So my name is Mingyu Ji, and my office is Mala 4214. And so you can see my information here. So yeah, my email, my website, and also I have a YouTube channel. So basically, so I recorded all my previous class before, and so you can see I have a camera on the back, right? So I have some audio devices. So I will try to record every class and try to put that on YouTube in case you cannot come, so you can watch the class later. Okay, but so I will try to do that, you know. So no promise. So basically, we need some processing for the video. So I will try to finish all the processing in the data of each class. But there might be some delay in some cases in case I'm busy or I travel. Therefore, it's better for you to still come to the class. But in case you have the other errands, and just feel free to go to do that. So probably we're gonna have all the videos in the end. Okay. So can you hear me? Is my voice okay? Okay. So so if you have any questions or comments, right, just stop me at any time. Okay. Yeah, and so my lab is Edge AI Lab. So basically, those 4 areas are currently what I'm working on. So if you're interested in kind of research, and if you're interested in my areas, so please feel free to talk to me about this. So basically, the 4 areas is the first one is machine learning. So I focus on distributed machine learning, and I do cloud and edge computing, right? If you're interested in like Amazon AWS or whatever, so I'm also doing something like that. And the third area is very related to our class. So it's about wireless communication and the networking. So we call that 6G because 6G is kind of the next generation, but I do all kinds of stuff here. So, and in the end, I also design some Internet of Things networks, like sensor networks and so on, right? We have some real systems for that. Okay, so yeah, any question about myself? Okay, if no, yeah, let's go on. So this is our today's agenda. So basically, we're going to talk about the syllabus first, right, to let you know what we're going to do for this class. And then we're going to talk some big pictures about wireless systems or general communication systems and digital communication systems, right? And then, so we're going to talk about the history of telecommunications, okay? And then that's it. So there's no anything technical today, but I promise you that from the next lecture, you're going to see lots of formulas, okay? Okay, so far so good. Okay, so now let's see the syllabus. So you can find the syllabus on Canvas. So I just uploaded, probably, yeah. I thought I uploaded, but I didn't. So I just uploaded, but I'll show you here. So it's a pretty long syllabus. I will not going to cover everything here, but just important stuff. So yeah, again, here's my information. Oh, by the way, so did you all sign up for labs? So if you haven't, please sign up for labs. I'll talk the labs later. Okay, so basically, so one thing important here is that for office hours, so I don't put regular office hours here, right? I have open door policy. Normally, I'm in my office. Yeah, roughly speaking, like from before 9 until probably 3:30 or 4. Yeah, I think there are 2 days I have to leave early every week, right? If you have any question, and just stop by my office, and we can discuss it, okay? And so if that is not convenient for you, then just send me an email, shoot me an email, right? We can discuss that over Zoom. Okay, so normally what I do before is that, normally you're going to work, very late, right? For labs, homework, and so on, right? If at night, so, like 10 p.m., right? So you want to talk to me, it's still okay. So I sleep very late. So I always talk to students, around 10, 11 p.m. Okay, I'm okay for that, right? Don't be shy. Okay, yes, it's not an easy class, by the way. So it's a pretty dense class. So, okay, here's the course description. You can read it. So basically, so we're gonna teach you a very big picture of wireless communication, right? So normally, when we say wireless communication or wireless networks, so usually we mean different things, right? For wireless communication, we mean the physical layer stuff, right? For a communication system, we have layers, right? Who heard of these layers? Physical layer, link layer, MAC layer, networking layer, and the transportation layer. Okay, so basically, yeah, the reason I have layers is that designing a communication system is a generally very hard problem, right? So I've simplified our design. For example, in the physical layer, which is covered in this class, so we only talk about point-to-point communications, right? Like, I'm a transmitter, you are a receiver, then how can I transmit something from me to you, right? So this is what is covered in this class, right? So what is not covered is a networking, related topics. For example, let's say if me and you want to transmit something to somebody else, right? So, and we want to transmit something at the same time, and how can we deal with this? Like Wi-Fi, right? So everybody is trying to send something to the Wi-Fi access point, right? How can we do that, right? So if everybody send at the same time, then the packet will be, corrupted, right? Then how can we deal with that? So that is not covered here, okay? So we call that point-to-point communication. And you may heard of the word like end-to-end communication, right? If it's end-to-end, so it basically means higher layer networking stuff, right? End-to-end basically means that, for example, if I want to watch a movie, right, and then I will send a request to YouTube, for example, right? And the communication from me to YouTube is end-to-end communication, right? So I have many stuff going on. I need to send my request to the Wi-Fi router first, and then the Wi-Fi router will send something to wireline connection, and then so on until it reaches YouTube, right? So that's end-to-end communication. Okay. So in this class, we're going to cover the most basic, exactly how information can be transmitted, right? Like point to point, right? Or sometimes we can think that as broadcasting, like FM, AM, radio broadcasting, right? So there's a one transmitter, and then everybody can hear, right? That's also covered in our class. Okay, great. So that's basically the course description, and we have lots of learning objectives. You can read it. Okay. So I think the basic, very important stuff here in our class is Fourier transform, because almost all the wireless communication are based on Fourier transform. Okay, so who knows Fourier transform? Okay, great. Yeah, if you forget it, yeah, don't worry. So I'll definitely recover it, and I'm sure you're gonna remember it later. Okay, yeah, that's our learning objectives, and here are the co-requisite, prerequisite, and you'll see it. And those are the grade distribution. So we have 15% for homework. Okay, and I'll tell you how many homework we're gonna have, and we have 35% for labs. So lab is a very important component in our class. Okay, and we have one midterm and one final, and each of them is 25%. Okay. Oh, by the way, I forgot to mention TA, right? I'll probably see that later. Yeah, I'll see that later. So we don't have any TA yet, but don't worry. Okay, and the next section is about ABAT, right? So who heard of ABAT? Yeah, Yeah, probably don't need to worry too much about it. Just list what are A-BET is basically they have lots of point, and we're trying to cover all of them using different courses, right? For this class, we're going to cover the first bullet and this one. And the first one is high. So basically, it's a very it's very well designed engineering kind of class. We use math to solve complicated engineering problems. Okay, and also since we have labs, right? And some of the labs are really real, right? That is, when you need to transmit real data, you need to, receive the real data and then do some signal processing. Okay, so we have some component for the lab and experiment and stuff. Okay, so those are A-BET. And course logistics. Okay, TA information, I'll add it later. So you can, if you see, can you see in your Canvas, can you see other people or only yourself? Can you see who the TA is? Yeah, I add a TA here. It's not official yet, but 99% he'll be our TA. So that's my graduate student. So normally we have very good undergrads to do the TA for this class. But this time, unfortunately, none of them are available. So they either graduated or they have some other stuff to do. Okay, so I put my student there, so I'll update it, and you'll see his information. So basically, the main job of the TA is for your labs. Okay, so of course, I will also help you with your labs, but TA will actually go to the labs and help you. Okay, and yeah, of course, if you have any question regarding lab, just feel free to ask me. Right? If I know, I will definitely tell you. Okay, great. And any questions so far? Okay, so next thing is our textbook. So this is our textbook. So we have some homework from it. So it's a required book. Okay, and either 4th or 5th edition is fine. So yeah, because this is kind of very busy class. I don't think there are huge differences, and either of them is fine. And there are some other textbook you can try. Okay, and this is a good one, but it's not required. Okay, and for the software, so we use GNU Radio. Of course, we use Python. Okay, and we also use GNU Radio. So that's kind of an important thing. So I suggest you to install that today. So I think I put something on Canvas. Let's see. Oh, by the way, you're going to see my style. So basically, I'll put everything under pages and also under files. Under files, I didn't do many organization yet, but I will organize stuff. So basically, under pages, I'll put everything there. Okay, and now you have some Python resources and you have some SDR info. So yeah, those are the, I'll talk about that later. Yeah, I'll also put the GNU Radio stuff here. I didn't put that yet. So basically, you have to install GNU Radio as soon as possible. Okay, I promise you that I will upload that today. Okay, so how many of you using MacBook? How many of you use Windows? Any Linux? Say again?
Subsystem, WSL.
It should be fine. Yeah, I mean, for each system, because GNU Radio is open source, you're going to have some problems, right? But I think, most of the people using Windows and Mac, I think we have detailed instruction there. But for Linux, I think it should be fine. But right, using Linux, so yeah, we may have some problems. Okay, great. And next is the final grade distribution. Yeah, this is our grade. So we have, if you are about 90%, it's A, and so on. So see, I have everything here. I have A minus, B plus, and whatever. Okay. Yeah, because this is my first time to teach this class here. So I taught that in Utah before. I came from Utah, by the way. So I was in Utah for like 8 years. But so I'm not sure exactly how you're gonna perform. Okay, so it is possible that we're going to curve it. So yeah, if everybody got below 80, so we're going to curve it, right? But it depends on your performance. Okay, but this is our idea so far. Okay, and then attendance policy. So basically, the attendance is not required. It's strongly encouraged, right? Because my video may not be uploaded online, in time. So definitely I always suggest you to come. And so basically, we don't have any makeup exam, right? We don't have makeup final, makeup midterm. Okay, so you have to come for that. Yeah, any questions? Okay, great. Okay, so next, let's talk about details about homeworks and labs, so on. So for homework, at this moment, I just follow, the previous instructor. So I have 5 homeworks in total. Okay, so it's not very heavy, but each of the homework might be a little bit long. Okay, but basically, most of the homeworks are like, problem solving. So mathematical problem solving, right? To compute something basically. And it is possible that you're going to use some Python tool, like you may use Jupyter Notebook or using some other stuff, right? Yeah. Okay, and about late policy. So basically, so for each homework, obviously we're going to have some deadlines, right? And so if you're late for 1 day, by the way, each homework will have like 10 points, and if you're late for 1 day, so I'll subtract 2 points. Okay. So here is an example, right? Like let's say, so if you're 1 day late, and then if you got a 9, then your grade will be changed to 7. Okay, and weekend doesn't count. Okay, for example, if the due date is Friday, then you submit on Monday, right? It's only like 1 day late. Okay, is that clear? Mm-hmm. And for homework, we have like 2 homework, one exams. We have 1 midterm and 1 final. And the final is not comprehensive. So the midterm will cover the first half of the class, and final will cover the second half of the class. Okay. And for lab assignment, so so basically we have 10 labs in total. Actually, we have 11 labs. So the first one, the reason I said start on January 15th is that, or next week, right? Doesn't matter. So including the very first lab, we call that lab 0, right? Lab 0, it just asks you to install all the software. Okay, so I put details of lab 0 as soon as possible, but for lab 0, you just need to install GNU Radio, Python, and so on. Okay, so did you use Python before? So who have not used Python before? Yeah, not many. So it's not that hard. Did you use MATLAB? You use MATLAB. Okay, great. I don't think, in terms of for the communication purpose, I don't think there's a huge difference between Python and MATLAB, right? So Python is a little bit, more real programming language compared to MATLAB, right? But I don't think the functions are extremely different, and so on. Okay, and those are the labs. And for the labs, in the first few labs, so basically you're gonna, it's all software based, right? So you can come to the lab, or you just do that at home. It doesn't matter. It depends on your preference, right? Yeah, if you come to the lab, the TA will be probably there to help you. Okay, and later, I think maybe you start from lab 3. So we're gonna need some, this GNU Radio component, right? So maybe let me talk a little bit here. So for the GNU Radio, the SDR component, software-defined radio. So basically, a software-defined radio. So who heard of that before? Software-defined radio? Yeah. Okay. So basically, that is, that is a device. It's like a computer. So we can program on it, and then transmit whatever we like. Depends on the hardware capability. Okay. It's a like computer for communication. Okay. And so in this class, so we're gonna use this RTL SDR. This RTL SDR is very small. You can read it later. So basically, it's a dongle. So I put lots of, I think either of them is fine. I put lots of links here, but I think the best thing is the first one, right? Because it's the cheapest, and it suffices for our use. Let me see. Yeah, this is the one. Yes, like a dongle. I had one, but I I used a different backpack, so I forgot it at home. But this is how it looks like. So everyone has to buy this. Would that be okay? Yeah, so it's a little bit pricey. I think it's much more expensive than before. Yeah, but you have to buy that. Okay, and I think I wrote I suggest you to buy that before the end of this month, but it only take 2 days. So yeah, buy that as soon as possible. You can play around with it. So basically, this is a wireless receiver. Okay, so what we're going to do with it is that, because over the air we have lots of signals. For example, we have radio signals, right, like the FM, AM, right? So we're going to use that to, decode or, recover the signals over the air. Okay, so that's one of our lab topics. Okay, great. Any question for lab so far? Yeah, you can come to the lab from next week, right? This week is fine. Oh, by the way, and also for the lab, for each lab you have to write a report, except for lab 0. Okay, lab 0, I think you just need if you have a question, just ask. I think it's okay because you need to install all the software. Okay, but I think starting from lab 1, you'll need to write down something. I'll let you know exactly what is needed. Okay, and the late policy is the same as the homework, right? If you're late for 1 day, you're going to be subtracted to 2 points, right? But there are exceptions, right? So, yeah, for example, if you have an emergency, feel free to send me an email, right? So I don't want to push you to the extreme, right? So if you have personal emergency, just let me know, okay? So we can discuss about it. Okay, and yeah, teaching and learning methods, course policies. So for the class structure, it's just normal lectures. So I will just skip that. It's not so important. And sometimes I may do surveys to ask you about feedback, right? But if you have any suggestions for this lab, for this class, just let me know, okay? So we can improve it. And okay, so it's possible that if everybody agree or most of people agree, we can modify our syllabus and our rules, right? If that's needed, just let me know. So we're gonna vote in class. Okay, for the collaboration, so it's strongly encouraged, especially for labs, right? So you can definitely collaborate to do stuff, but if you use others' method, for example, for a lab, right? Sometimes we need others' help, right? But a little bit help is fine. But if you really cannot do it, and you got lots of help from others, so you can write it on your lab report. Okay, so that will not impact your grade. Okay, so we just don't want plagiarism, right? Like this point, right? So cheating and plagiarism is totally forbidden, obviously, right? But you can collaborate. Yeah, as long as you tell me, I think that'll be okay. Okay, and then university honesty policy, you can read it. So yeah, and so I got the rule of in-class recording from the previous instructor. So basically, you can read whatever is here, but so you can record whatever you want. You can take pictures, record, but I'll put everything online, right? All the stuff, all my own personal lecture notes, right? All the slides. So everything you can imagine, everything will be online. Okay. Oh, by the way, so there will be a course website as well, Canvas and the course website. Okay, they will be the same, right? I didn't make that yet. I'll make that as soon as possible. But if you don't like Canvas, using the course website is also okay. Okay, and maybe I can. Yeah, it's hard to find probably. Yeah, maybe let me try to show you something. Yeah, this is my previous website, and and for my previous teaching, so I have some lecture notes here. For example, this is a communication lecture, so I have this kind of website. You have syllabus, slides, and video as well, I think, right? So we're gonna have something very similar to this, okay? And if you want, you can take a look. Okay, I think that's everything I want to cover. And if you need any help or have a health problem, just read it. We have all the related information here. Okay, so that's the course syllabus. Any questions? Great. If no question, let's continue for our slides. Full screen mode. Okay, so now let's talk a little bit about the big picture. So it's a little bit small. Hopefully you can still see it. I got it from the book, basically. So this is a normal communication system, right? So communication system is nothing but what? It's called a system, right? If you learn signal system, so the communication system meaning that it's a system, okay? And later you're gonna see that, And in our class, the communication system is a linear system, right? If for a linear system, so what happened? If a signal passing through a linear system, so what will happen? So what is the output? It's kind of a quiz, right? So you have a LTI, linear time invariant system, and what is the relationship between the input signal and output signal? Yeah. Say again? A line. I mean, we have a system in between, right? So a line meaning the same? Or?
Well, yeah, like the output, like it's gonna, their output is gonna be like a linear function of.
Oh, very good, very good. Yeah, very good. Yeah. that's definitely true. Yeah. Yeah. One because we have also time invariant, condition. It's a convolution. Yeah. Yeah, who heard of convolution or who knows it? Remember? Great. Yeah, convolution is what happened for a linear time invariant system, right? So the input signal will convolute the system, so which is our channel, so that we're going to cover later in the class. And then the convolution between the input and channel, then the output is the received signal, basically. Okay? Yeah, that's basically what is exactly happening. But on this diagram, with first of all, we need to first, change our input messages into some signal that we can send, right? So for example, let's say the input message can be audio or speech signal, okay? Then we need to change it into like 0, 1s as today, right? Digital signal. And then we're gonna use a transmitter to send it over the air and then pass through the channel. It could be a wireless channel. Right, and then we have a receiver to receive it, and then we need, map it back to another audio signal that we can hear, we can listen. Okay, so that's basically a big picture of a communication system, a general communication system. Okay, so here are some very general questions, right, which are kind of obvious, but I still want to mention them. So what is communication? Okay, so communication basically is nothing but transmitting information from one place to another place. Right, so you want to send something, right, and you want to duplicate the same stuff in another place, right? That's the idea, okay? And the channel is just a physical medium between them. So we'll have a few examples of the channel. For example, I say if the channel is air, then we could use acoustic waves to communicate, like what we're doing now, right? So I'm talking, and then you can definitely receive it, right? It's acoustic waves. So that can be transmitted over the air. And similarly, if we want to the underwater system, we have to also use acoustic waves. Okay, and if we're in a space, also air is fine, but if we're in space, there's nothing in between. And then we can use radio frequency or electromagnetic waves, okay, to transmit. And the reason this is red is that, so that's the focus of our class. Okay, so we're going to focus on RF communication. Okay, and also if there's nothing, we can transmit photons as well. And if we have some real medium like optical fiber, right? So we can transmit light in that, to represent our information. And if a metal wire, like twisted wire pair, coaxial cable, waveguide, and so on, right? Then we transmit electronic signals over there, right? Like voltage. Okay. So I think most of people will use that, in their home for wireline networking, right? And for example, I have like Ethernet, right? So the FireWire, USB FireWire, and DSL, and so on. Okay. And okay, so here are some advantages of RF. So RF is probably one of the most popular way to communicate, like cell phone, right, laptop, right, or Wi-Fi, 5G, right, they're all RF, based on RF. So why we use RF? So here are some advantages, right? So basically, RF can pass through material. It can pass through the wall, right? If we have a wall between transmitter and receiver, it doesn't matter as long as the wall is okay, it's not metal, right? So we can do that, and and it can transmit over a very long distance without putting a wire, right? That's a big advantage, and the most important thing is that so we can modulate the information using using RF, right? So we're gonna see later in the class that what we mean by that exactly. So basically, we can modulate the information. Okay, and it's invisible, not like optical fiber, right? It's invisible, so it does not disturb anyone. And for some applications, so we can use it as a radar, right? So for the reason I'm using radar is that it's kind of a sensing system, right? So RF can also use for sensing, instead of besides communication, or besides transmitting information. Okay, and later on we're going to see that some other advantage is that we can divide up the communication medium. So basically, we can reuse a lot of stuff here, right? We can reuse frequency, we can reuse time, right? Reuse space. Okay, so that means we can divide up the communication medium. Okay, and also we have some problems for RF, right? So it's not all good, right? So so here are some disadvantage of RF. So first one is that it's unguided. It's not like optical fiber, right? We have a thing in between. So the light will traverse, right, in the optical fiber, but for RF, it's not, right? It transmits everywhere, okay? I mean, if we do not do anything, right? Sometimes we can do something, but so, it's unguided, okay? And we have very strong signal attenuation. So later on, we're going to see how strong that is. It's very, very strong signal attenuation. So that's why, wireless signal is kind of safe, right? If we have our phone, which is or wireless access point, it's 1 meter away from us, so we're safe, right? Why is that? The reason is the attenuation is so high, okay? So we're going to see probably in the next class how high that is. It's very, very high. And the other problem for RF is that we have very strong interference, right? Like I said, if I transmit, others transmit at the same time, so our signal, will be corrupted, okay? So it's a very bad thing. So that's one of the main difference between wireless communication and wireline communication. Wireline communication, we don't have interference. I have 2 lines there. That's it, right? Okay, and then in order to transmit, we need antennas. Okay, and then designing antenna is a huge problem. Okay, so for different frequency, for different requirement, we need to design different antennas, and also how to put antenna into our phone and stuff. Those are not easy engineering problems. Okay, great. So now, yeah, in our class, so probably we'll have half of the class is analog communication, and half of the class is digital communication. Okay, so we're going to see the difference between analog and the digital later, right? But the picture I give you is a general communication system, but here is a general picture for digital communication system, right? Which is a little bit more complex than analog communication. So the reason I put it here is that, it's very important, right? Because almost all of our devices are digital, right? Who still listen FM? Yeah, not many. Oh, you, very good. Yeah, yeah, that's the analog communication system, right? AM, FM, they're analog, but most of our system, Wi-Fi, our phone, 5G, they're all digital, right? So those are what we're really using today, right? I want to emphasize a little bit. So I'll not cover the details of it. So basically, the most important thing, right? If you learn a digital communication class, for example, you're going to only learn this component and this component, encoder, decoder, and the modulator, demodulator. Okay, so that's the thing you're going to learn if you are in a single digital communication class. Okay, and so basically, so we're not going to cover this in our class, but we're going to cover this in our class, right? So modulator, demodulator is called modem. Okay, so basically, yeah, I think you can read what is really happening here, but in one word for modem, so that is we need to change our signal to fit our medium. Okay, so it's not like any signal can be transmitted using RF waves, right? We need to do something here, you know. For example, so we have to modulate our signal to certain frequencies. Okay, so I'll explain you later what I mean exactly in later classes. But you know, roughly speaking, so our air, or you know, the channel of our air is like multiple, how to say, tunnels. Okay, so for you know, signal can only transmit in you know different tunnels. Okay, and those tunnels are determined by frequencies, right? So if we want to transmit a signal, you know, the frequency is not right, we need to change the signal of our frequency. So change the frequency of our signal, and then you know make it pass through the certain tunnel. Okay, so that's modulation. Okay, yeah, that's a big part in our class. For the analog communication, we also need to deal with that. Okay. Okay, so here are some history for telecommunication. So yeah, so those are some early history. Actually, the communication starting from very early, from 1867, right? First, Maxwell, you know, predict this electromagnetic wave, and Hertz proved the existence of the electromagnetic waves. Okay, and later Bradley developed, you know, the cohere for the detecting the radio waves, and then Marconi, he demonstrated wireless communication basically. Okay, and this guy, who heard of this guy? Yeah, great. So he is, you know, one of the biggest guy in communication. So if you're in IEEE a communication society, so I think there are like many prizes award named after him. Okay, Marconi Prize. Okay, and let's talk about the birth of radio. Okay, in 1897, so Marconi awarded the patent for the wireless telegraph. Okay, and then the first Marconi station established on the Needles Island to communicate with the English coast, right? And here you'll see this is I think the world's first radio station, and okay, and Marconi also awarded the English patent for this. Yeah, and in 1998, so we established communication between England and France. Okay, there's some history, and after that we can transmit over the ocean, and so you can see. So this is how they built the system. That's an old picture. And so the first bidirectional communication across the Atlantic happening in 1902. And after that, Marconi got the Nobel Prize for physics. Okay, so you can see, you know, for wireless communication, it only happened like, you know, 100 years ago, right? Not a very long time ago. Okay, and later, so we can transmit the voice over radio. And so yeah, we're going to talk a lot of this in our class. We're going to talk about AM, FM. So the main application of that is a voice over radio, right? And I will not read those, but you can see. So you can see what is really happening here. Okay, and in 1935, so we have FM modulation, and demonstrated by Armstrong. Okay, so we're going to talk very details about FM. You're going to have labs on FM as well. So although that's not very important, but you know, it's still working. We still listen to, you still listen to FM radio, so which is nice. And you will learn why FM has so good quality. Okay. Okay, so then it's video, right? So we have television, right? Television starts basically, television broadcasting starts from 1928, right? And then we have our US standard, and then we built our first cable TV system, and in 1954, so we have our colored standard, right? And then we have satellite TV broadcasting in 1967. Okay, which is really not a very long time ago. Okay. Okay. Yeah, and from 1998, So things starting, we transfer things to digital. Okay, so basically by digital I mean we represent everything using 0 and 1s. Okay, and you can see, so in 1998 we have our first digital TV broadcasting, and in 2009, so we shut down the analog TV stations in the U.S. Okay, but we didn't shut it down for FM, AM. So we can still listen AM, by the way. Okay. Yeah, and we don't have any analog TV broadcasting anymore, I guess. Okay, and here we talk a little bit about telephony. So basically, it starts from 1946, and this is our first telephone system. And in 1949, so FCC recognized mobile radio as a new class of services, right? And this is very, very important, okay? Because mobile communication is probably one of the most important communication, right? Because our phones is mobile communication, okay? And probably that's the largest industry as well, right? And you can see the increasing of the mobile users, from 1940. Until, yeah, we're going to see that in the next class, next slide probably, but here in 1976, so Bell mobile phone has a 547 paid customer using 12 channels in New York City area, okay, and we have a long waiting list for that. People want to use, mobile phones, and here is a very early version of the mobile phone. So that happening in 1973. So can you imagine? So around that time, we have our first mobile phone. Oh, by the way, who used this kind of phone before? Yeah, you're probably too young for that, right? So I think, when I was very little, so I used something very similar to this, right? So it's like, not bidirectional, not duplex. So it's like, when I talk, the other cannot talk. So we really need to cooperate to make phone calls, right? So kind of very nice, very interesting experience. I think I used that around maybe 8 or 9. So yeah, I still remember that because it's really, really cool.
Like a walkie-talkie?
It's not a walkie-talkie, it's a telephone. It's a mobile phone, like your cell phone, like this. But it's like this big, extremely heavy, right? Yeah, walkie-talkie is relatively easy. Yeah, but you can dial it to a fixed line and then talk. Yeah, you can listen something, right? If you listen beep, then you can talk. And then I think you need to hold something, and then if you release, and the other will hear the sound, and then they can talk. Yeah. But if the other people didn't know that, you cannot communicate very efficiently. Yeah, it's pretty bad. Okay, and after that, we have an explosion on the mobile communication, right? So basically, we have our old systems here, but the first real system is this one, the GSM, right? Who heard of GSM before? Yeah, probably who used a GSM phone before, like this big phone? Use that, very nice. Yeah, later on we have, so the GSM is a technology's name, it's a standard. And then we changed it from GSM to so-called CDMA, right? And I think they start from the United States, and Qualcomm have lots of patents on that. Okay. And here you can see the communication rate, right? So for this CDMA system, so this is the rate. At most, we can transmit 115 kilobits per second, okay? And later, so we improved that a lot, right? So after that, we have our third generation system. So that's based on CDMA, and we have many subscribers for that. And meanwhile, so we also develop other kind of communication technology like Bluetooth or Wi-Fi and so on, right? Okay, and here are some numbers for mobile subscribers. So basically, you can see the numbers here. So from 2004, so we have 1.4 billion 1.4 in total, and the US will have 170 million, and this number keep increasing, right? And you can see the rate also increasing, right? For 4G LTE, so we have 1 gigabit per second, and for 5G we have 10 gigabits per second. okay, for the communication rate. Yo, by the way, for your mobile phone, so who use unlimited data? Yeah, most of you. Okay. So do you think it's too expensive? No? Okay. Only me? Yeah, I think it's very expensive. Yeah, you know, I think I only use unlimited data for like half a year. Before that, you only use 2 giga or 4 giga. Yeah, it seems not enough, then I change it. But I think it's too expensive. And you can see, so this basically tells you that we have more phones than people around 22nd. Okay. Yeah, I think everybody knows that by now. And so those are the developed lines for another very important technology. In my opinion, probably that's not in my opinion. I think that's the thing that what people use more than their cell phone, right? I think everybody uses Wi-Fi a lot, right? This is the development of Wi-Fi. Okay, so starting from 1997, and you can read we have all the releases, and we have all the fancy number. Yeah, it's all called 802.11. So we have B, A, G, N, A, C, A, X. So, oh, by the way, so I worked in Broadcom before. Broadcom is a company that develops Wi-Fi chips and standardization. Okay, who heard of Broadcom? Oh, great. I worked there before, so I was part of the standardization, so for the AX. Okay, and it's very exciting. So later it's called Wi-Fi 6, and now for the current Wi-Fi, which releases last year, so it's called Wi-Fi 7, and this is the communication rate. You can see it's pretty impressive. Okay, and I think in 2028, we're going to have our next generation for Wi-Fi. Okay, and you can see this is the increase of the throughput of Wi-Fi, so it's pretty impressive. Okay, and and this is indicate the number of wireless devices, not only phones, right? So because now we have lots of these IoT devices, smart watches, right, and smart home devices, right? If you count the number of devices here, you can see that. So we have a lot of it, right? This 22, what's the unit for that? Probably billion, right? In billions, right? So we have 22.2 billion devices in total in 2021, right? So now the number will be even bigger. Okay, great. And here are some other wireless technologies, right? So by the way, all the basic principle we'll learn in this class can be applied for all of them, right? So we have RFID, so this is a passive communication standard, and we have Zigbee, so normally we use that for sensor network, and we also have LoRa, so which is kind of new wireless technology, and we use that to transmit over a very long distance, right? On paper, it says for one hop, LoRa can transmit like 30 miles, right? But in practice, it's like 800 meters. Yeah, so I mean, it's just different. Okay, so we're almost out of time. So I also wrote some history of modem, so for the digital communication. So I'll skip it since we don't have time. But I want to emphasize one final thing in the end, which is information theory. So this basically is a very important theory, and also, so my PhD was on this topic. Okay, so basically, information theory starts from Carl Shannon from 1948. So this basically tells you that how many number of bits you can transmit over the air. Okay, yeah, because before, we just can transmit, but we have no idea how much we can transmit, right? Because we turn to digital, right? In digital, we can measure things in bits, right? By using this kind of theory, so we can actually know what is the maximum number of bits we can transmit given the channel. So which is very, very important. So this is a fundamental theory for communication and for data storage. Okay, so if you want to learn more about it, so I'll be happy to tell you about it. Okay, and you can read what I wrote here, and I think that'll be it for this class. So from the next one, so we're gonna introduce the real stuff. So basically, I'll say just one last thing. So the style of my lecture will be like this. So if we want to cover lots of basic concepts, right, many words, so I'll use slide. So if you want to cover mathematical details, technical stuff, I'll just use board to write. But I will share everything online. Sounds good? Okay, great. See you on Wednesday.